Now it's time for some exercises. Let's work on calculating acceleration. First of all, let's do a little concept review. So what do you think? Is acceleration a scalar or a vector? If you picked a vector, you're right. Since acceleration is dependent on velocity, and velocity is a vector, acceleration must also be a vector. So if acceleration is a vector, does it have magnitude, direction, or both? If you picked both, you're right. All vectors have both magnitude and direction. Here's another quick question. Can you write out the equation for acceleration? You said that acceleration is equal to delta v over delta t. You're right. How about the units? The units of acceleration are the units of velocity, meters per second, divided by the unit of time, seconds. So we have meters per second squared, or meters per second. Now let's do some math. Let's say our T-Rex is traveling east at a nice clip of 2 meters per second. Then he speeds up to 10 meters per second. This change takes him 2 seconds. Can you calculate his acceleration? Feel free to pause the video. Let's see here. His final velocity is 10 meters per second minus his initial velocity, 2 meters per second, over the change in time, 2 seconds. This is equal to 8 meters per second per 2 seconds, or 4 meters per second squared. This problem is a little bit different because it involves deceleration or negative acceleration. This means our T-Rex is going to slow down. Our T-Rex starts off at 60 miles per hour or 27 meters per second, riding on a Ferrari. Unfortunately, he isn't wearing a seatbelt, so he falls off and hits the ground. Then he's at rest. Rest is a state where you're at 0 meters per second, 0 velocity. Can you calculate his negative acceleration or his deceleration? Alright, let's give this a shot. Our T-Rex has a final velocity of 0 meters per second minus an initial velocity of 27 meters per second divided by the amount of time, 1 second. This is equal to negative 27 meters per second. That's an awfully fast deceleration. This problem is a little bit different because our T-Rex moves in 2 different directions. Looks like he's indecisive today. First, he's walking 12 meters per second in the negative direction. Then he changes his mind and starts moving at 3 meters per second in the positive direction. His change of velocity takes him 2 seconds. Can you calculate his acceleration? Let's see. His initial velocity is 12 meters per second, but in the negative direction. So let's say negative 12 meters per second. His final velocity is 3 meters per second in the positive direction. So his final velocity minus his initial velocity, negative 12 meters per second, actually is an addition problem, so we get 15 meters per second. Then we have to divide by the change in time, 2 seconds. So we get 7.5 meters per second. Remember, this change in acceleration is in the positive direction because the overall change in velocity is from negative to positive. Very well done.